Today we're going to continue talking about ratios and another way of comparing values, which are proportions. So we've talked about creating equivalent ratios and ratio tables. And what we call two ratios, when two ratios are equal to each other, so when two ratios are equal, they form a proportion. Proportion. Okay, so when two ratios are equal, they make a proportion. Okay, you often hear the word proportional, right? Proportional means to scale up or to scale down, but to maintain its shape. Okay, so just as a quick review, ratios are a comparison of two or more numbers. Okay. And you should be making sure to write this down in your notes as well. And there's three different ways to write them. We can write them as a fraction, which is the most common form, 4/5 or 4 to 5. We can write them as, with words, 4 to 5, or with a colon, 4 to 5, or 4 out of 5. So let's take a look now at proportions. So if we have two ratios, in the past we have been trying to determine if they were a proportion by simplifying the fraction. And that's a nice, quick, easy method. Two ratios that are equivalent or equal will simplify to the same. Another method of doing that is by setting them equal to each other and using cross multiplication. Use cross multiplication to determine if it's a proportion. Cross multiplication. Cross multiplication. And you'll notice that there's an equal sign between the proportions. That means it's an equation, right? So let's take a look and use some cross multiplication to decide if this is a proportion. So to cross multiply, I'm not sure if you have done this before or not. Cross multiply, we call it cross multiply because we're going to multiply diagonally. It does not matter whether you start with the top or the bottom, but I usually start from the top, and I'm going to multiply in like a crisscross shape. So first I'm going to multiply 1 times 18. 1 times 18 we know to be equal to 18. Okay? And that's going to go on one side of our equation. Then we're going to write our equal sign because of course this is an equation. And then we're going to cross multiply the other two values diagonally. Okay? So diagonally going up and down. 6 times 3 is 18. And you'll notice that when I was finished with my cross multiplication, I get two values that are equal to each other. 18 is in fact equal to 18. So if the two numbers, when you're done cross multiplying, are equal in the equation, if you get a true equation, then it is in fact a proportion. So this example is proportional. You could check this by dividing each fraction with your calculator or simplifying. We have 1/6, and I can simplify 3 out of 18 by dividing by 3. 3 divided by 3 is 1, and 18 divided by 3 is 6. So I can see that they both simplify to 1/6 as well. But for today, we're going to practice using proportions and using cross multiplication to see whether or not that's proportional or not. Oh, looks like we have forgotten an R here. Problems. There we go. So let's try a couple more examples, and then I'll have you try a couple together, okay? Or by yourself. So remember, we start, and it doesn't matter if you start at the top or bottom, as long as you go from top to bottom top on one, bottom on the other. 2 times 30 is 60. And if I look at the other side, top to bottom, kind of looks like a little butterfly, doesn't it? Right? 5 times 11 is equal to 55. So I end up with a proportion where 60 is supposed to be equal to 55. Because these two numbers are not equal, 60 does not equal 55, this is not true. And I know that these are not equivalent ratios. They're not proportional. They do not equal the same value. Okay, let's try another one. 8 times 21. You can feel free to use Desmos, and that's probably the quickest way for you. And you'll notice that I'm going from the top to bottom this time, going the other way, just to show you that it doesn't matter which one you do first. Top to bottom, 8 times 21. 8 times 1 is 8, and then 8 times 2 is 16. So we get 168 on this side, equals, top to bottom, 3 times 56. So 3 times 6 is 18. Carry the 1. And 3 times 5 is 15, plus the 1 that we carried is 16. So do you think this one's proportional? It sure is. They're equal to each other. So I know that this one is in fact proportional. Go ahead and pause the video and take a moment to solve the next two problems. When you turn it back on, we can look at them together. So let's take a look. For number 3, you should have gotten 120 is in fact equal to 120. So the two ratios of 5/12 and 10/24 are in fact proportional. For number 4, 196 is not equal to 168. So 4/7 and 24 out of 49 are not a proportion. Proportions can also be used to find a missing value. Okay? We can use cross multiplication again. Cross multiplication. We can use cross multiplication to solve proportions for a missing value. Okay? So we can multiply, do our cross multiplication, and you'll notice there's an x. We want to know if we have 2 as the numerator, what would the denominator have to be in order for it to be equivalent or equal to 5 out of 16? Now, typically, we look for a way to get from 5 to 2. We would scale down, but there's not a direct way of doing that. So we can use cross multiplication. Okay? I usually, in the cases where I'm solving for an x, start with the x. So these two, I have x times 5, and we just multiply them together, and we write them as 5 times x, or 5x. X is our unknown value. And then that's going to be equal to, on the other side, we cross multiply, 2 times 16, and we get 2 times 6 is 12, carry our 1. 2 times 1, or 10, is 20, plus the additional 10 is 30. Okay. Now you notice when we do this that we're going to get a value that is not even, and that's okay. We're going to use our calculator. Okay. So to get from here to here to solve this equation, if we want to get rid of the 5, we want to divide. We always divide by the number in front of x. So dividing gets rid of that number. And you're going to want to put that into your calculator in Desmos. So if you haven't already, make sure you have another tab open and open your Desmos application. Oops, I went to the wrong Desmos app. Okay, and we're looking at dividing 32 by 5. So we do 32 divided by 5, and I get 6.4. So we know that x has to be equal to 6.4. So going back to our problem, in order for us to have equivalent ratios or proportional ratios, if the numerator is 2, the denominator has to be 6.4. Okay? Let's try one more together. So 4 times 28, and this time we'll show you doing it on the other side. 4 times 28 is 112, and that's going to be equal to the variable, which in this case is y, times 6. We always put the number in front of the variable. Our next step is going to be to divide by whatever number is paired up with that variable. Since that's multiplication, we're doing the inverse. Okay? Then we're going to use our calculator to do the division. 112 divided by 6. And we end up with 18.66 repeating, or 18.67. Okay? 112 divided by 6, 18.7. So I know we'll round to 7. Okay? So in order for us to create a proportional relationship between 6/28 and 4 in the numerator, the denominator has to be 18.7. Being able to cross multiply to solve is very helpful when you think that you might need, when you might end up with a fractional or decimal result. You can also use ratio tables, so whichever you're more comfortable with. Let's go on and try a couple more practice problems. I'll do the first one with you, and then you can try the next 3 by yourself. Okay, so 14 times 12. Now, whenever you come across a value that is pretty big, like this one, we're encouraging you to use Desmos, okay? So 14 times 12, 168. Cool beans. So we have 168 on this side. And then on the other side, we're multiplying together 8 and the value we're trying to solve for. We're trying to figure out y. So 8 times y. And then our next step should be to what? Divide by the number with the variable. Okay. So we'll go back over to Desmos. We have 168, and I'm going to divide that by 8, and our answer is 21. So 168 divided by 8 is 21, and that's equal to y. Y has to be equal to 21. So 8 out of 14 would be proportional to 12 out of 21. Follow this example and pause here to complete the next 3. All right, so please take a moment to check your work. You should have cross-multiplied and then divided by 20 to get that p would have to be 12 to complete this proportion. For number 3, cross-multiply, divide by the number paired with the variable, 119, and you should have gotten that n would have to be 5 to complete the proportion. And finally, you cross-multiplied, and you divided by the number 15. It was paired up with the w. When you divided on both sides, you got w was equal to 24. So 9 out of 24 would be equal to 15 out of 40. let's summarize our steps. So to summarize our steps, to solve for a missing value, or to check and see if two ratios are in fact proportional, you cross multiply. So our first step is to cross multiply, right? Cross multiply. Multiply. And sometimes I even like to draw myself like a little picture to remind myself, hey, I've got to go, it's got to look like this, right? So you're going to cross multiply, and then after you cross multiply, you divide by the number I misspelled number. Let me change it. Aren't you glad I'm not your English teacher? Divide by the number paired with the variable. Okay, so to solve, first you cross multiply, then you find the number that is paired with the variable. We call that the coefficient, and you divide by that value. Okay? All right, so good luck on your practice, and I hope you have a great day.